1. What is super in Java? The super keyword in Java is a reference variable that points to the immediate parent class object. It's essential in inheritance scenarios when dealing with relationships between classes. Key uses of super: accessing parent class members. When a child class has a member with the same name as a parent class member, you can use super to explicitly access the parent class's version. Java. Class animal. String color equals white. Class dog extends animal. String color equals black. Void print color. System.out.println, color, / prints black. System.out.println, super.color, / prints white. Calling parent class constructors. The super keyword is used to invoke the parent class's constructor. It must be the first statement in a child class constructor. Java. Class parent. Parent, string name. System.out.println, parent constructor called with name, plus name. Class child extends parent. Child, string name. Super, name, / calling parent constructor. System.out.println, child constructor called. Important points. Super is a reference variable, not a keyword like this. You cannot use super in a static context. The default constructor of the parent class is called implicitly if you don't explicitly call a specific constructor using super. In essence, super provides a way to interact with the parent class from within a child class, enabling code reusability and proper object initialization. 2. How can constructor chaining be done by using the super keyword? Constructor chaining is the process of calling one constructor from another within the same class or a parent class. The super keyword is specifically used to call a constructor from the parent class. How it works. Inherit a class, create a child class that extends a parent class. Use super. Inside a child class constructor, use the super keyword to call a specific constructor of the parent class. Constructor execution. The called parent class constructor executes first, followed by the child class constructor's code. Example. Java. Class parent. String name. Int age. Parent, string name. This dot name equals name. Parent, string name, int age. This, name, / calling another constructor in the same class. This dot age equals age. Class child extends parent. String school. Child, string name, int age, string school. Super, name, age, / calling parent's parameterized constructor. This dot school equals school. Explanation. The child class inherits from the parent class. The child constructor calls the parent constructor with name and age using super, name, age. The parent constructor with two arguments is called first, which in turn calls the parent constructor with one argument using this, name. After the parent constructor finishes, the child constructor continues with its code, assigning the school value. Key points. Super must be the first statement in a child class constructor. It's essential for proper object initialization and avoiding redundant code. You can combine super with this for complex constructor chaining scenarios within the same class. By effectively using super in constructor chaining, you can improve code organization, reusability, and maintainability in your Java projects. 3. What are the main uses of the super keyword? Main uses of the super keyword in Java. The super keyword in Java is primarily used in inheritance scenarios to interact with the parent class. Its main purposes are 1. Accessing parent class members. When a child class has a member with the same name as a parent class member, super is used to explicitly access the parent class's version. 2. Calling parent class constructors. The super keyword is used to invoke a specific constructor of the parent class. It must be the first statement in a child class constructor. 4. What are the differences between this and super keyword? The this and super keywords in Java are used to refer to different objects within a class hierarchy. This keyword, super keyword, refers to the parent class object. Used to access members, variables and methods of the parent class. Used to call constructors of the parent class. Cannot be used in static contexts. Summary table. Feature. This. Super. Reference. Current object. Parent class object. Purpose. Access current object's members. Access parent class's members. Constructor. Call current class's constructor. Call parent class's constructor. Static context. Can be used. Cannot be used. Export to sheets. Example. Java. Class parent. String name. Class child extends parent. String name. Child, string name. Super, parent name, / calling parent's constructor. This dot name equals name, / setting child's name. Void print names. System.out.println, parent name, plus super.name. System.out.println, child name, plus this.name. In this example, super, parent name, calls the parent class's constructor. This .name equals name assigns the value to the child class's name variable. Super.name accesses the parent class's name variable. This .name accesses the child class's name variable. Key points. Both this and super are used to resolve ambiguity when there are members with the same name in both the parent and child classes. Super must be the first statement in a child class constructor if you want to call a specific parent constructor. By understanding the differences between this and super, you can effectively manage object relationships and code clarity in your Java programs. 5. What is the output of the following Java program? Here are some elements to consider when providing the code. Complete code. Ensure the code is self-contained and includes all necessary classes and imports. Formatting. Proper indentation and spacing enhance readability. Comments. Optional but helpful for explaining specific parts of the code. Example. If your code is Java. Public class example. Public static void main, string args. Int x equals 5. System.out.println, x asterisk 2. The output would be 10. 6. Can you use this, and super, both in a constructor? No, you cannot use both this, and super, in the same constructor. Here's why. Both must be the first statement, when used in a constructor, either this, or super, must be the first statement. Conflicting purposes. This is used to call another constructor within the same class, while super is used to call a constructor from the parent class. These actions are mutually exclusive. Example. Java. Class parent. Parent. System.out.println, parent constructor. Class child extends parent. Child. / This would cause a compilation error. / super. / this. However, you can use this, in one constructor to call another constructor in the same class, and then in the called constructor, use super, to call the parent class constructor. Java. Class child extends parent. Child. This, 10, / calling another constructor in the same class. Child, int value. Super, / calling parent class constructor. / 7. What is object cloning? Object cloning is the process of creating an exact copy of an existing object. This means creating a new instance of the object's class and initializing its fields with the same values as the original object. How it works. Clonable interface. The class whose objects you want to clone must implement the java.lang.clonable interface. This indicates that the class supports cloning. Overriding clone method. The clone method is inherited from the object class. To create a proper clone, you should override this method in your class. Shallow versus deep copy. The clone method by default performs a shallow copy, which means it creates a new object but copies only the references to objects within the original object, not the objects themselves. For deep copies, copying nested objects as well, you need to implement custom cloning logic. Example. Java. Import java.lang.clonable. Class employee implements clonable. Int ID. String name. Public employee, int ID, string name. This .id equals ID. This .name equals name. Add override. Protected object clone. Throws clone not supported exception. Return super.clone. Key points. The clone method is protected, so you can only access it within the class or its subclasses. The clone method throws a clone not supported exception if the class or its superclasses don't implement the clonable interface. Shallow copying can lead to unexpected behavior if the original object and its clone share references to mutable objects. In such cases, modifying one object will affect the other. When to use cloning. Creating copies of objects for modification without affecting the original object. Implementing undo/redo functionality. Passing copies of objects to methods instead of original objects to prevent unintended modifications. Note, while cloning is a powerful tool, it's important to use it judiciously. In many cases, creating new objects manually or using copy constructors might be more appropriate. 8. What is method overloading? Method overloading in Java is a feature that allows a class to have more than one method with the same name, provided their parameter lists, also called method signatures, are different. This means that methods can have the same name but must differ in the number of parameters, the type of parameters, or the order of parameters. Key points about method overloading. Same method name. All overloaded methods must have the same name. Different parameters. The methods must differ in their parameter lists. This difference can be in the number of parameters, the type of parameters, the order of parameters if they have different types. Return type. The return type of the method can be different, but the return type alone is not sufficient to overload a method. The parameter list must be different. Compile time polymorphism. Method overloading is an example of compile time polymorphism, or static polymorphism, where the correct method to call is determined at compile time based on the method signature. Examples of method overloading. Example 1. Different number of parameters. Java. Copy code. Class math operations. Int add, int a, int b. Return a plus b. Int add, int a, int b, int c. Return a plus b plus c. Public class main. Public static void main, string args. Math operations. Math equals new math operations. System.out.println, math.add, 5, 10, / calls the first add method. System.out.println, math.add, 5, 10, 15, / calls the second add method. Example 2. Different types of parameters. Java. Copy code. Class math operations. Int add, int a, int b. Return a plus b. Double add, double a, double b. Return a plus b. Public class main. Public static void main, string args. Math operations. Math equals new math operations. System.out.println, math.add, 5, 10, / calls the int add method. System.out.println, math.add, 5.5, 10.5, / calls the double add method. Example 3. Different order of parameters. Java. Copy code. Class display. Void show, int a, string b. System.out.println, integer, plus a plus, string, plus b. Void show, string b, int a. System.out.println, string, plus b plus, integer, plus a. Public class main. Public static void main, string args. Display equals new display. Display.show, 10, hello, / calls the first show method. Display.show, hello, 10, / calls the second show method. Benefits of method overloading. Code readability. Using the same method name for similar actions makes the code easier to read and understand. Reusability. Overloading allows reusing method names for different types of operations, reducing the need to create unique names for every variation. Convenience. It simplifies the class design by allowing multiple methods that perform similar actions but accept different inputs. What method overloading is not? Method overriding. Overloading is different from method overriding. Overloading occurs within the same class, whereas overriding happens when a subclass provides a specific implementation of a method that is already defined in its superclass. Based on return type alone, overloading cannot be based solely on different return types. The parameter list must differ. Conclusion. Method overloading is a powerful feature in Java that allows methods with the same name to perform different tasks based on the parameters provided. It enhances flexibility, readability, and maintainability in the code, making it a widely used feature in object-oriented programming.